Thank you very much for joining us here today, Matt. We're going to be talking about Human in the Loop a little bit. But I did want to say this is kind of interesting. We are your first interview as a Canadian citizen.
That's right. I became Canadian about half an hour ago.
Yeah, just like right from the ceremony. So congratulations. Right. Thank you for sharing this moment with us.
Thank you so much. I'm looking forward to some, I guess, poutine and maple syrup.
Yeah. Pick those. Those are good. Yeah. Start with that. Let's talk a little bit more about yourself.
Sure.
Can you tell me a little bit about who you are?
I love talking about myself.
Great.
So I've been doing reinforcement since 2003. I got into AI and reinforcement learning just because it was the coolest thing I could think of doing. I bounced around the U.S. for a while, and then I came up here to Edmonton at the end of 2017. So now I'm at the university, and I get to work with lots of good students on lots of cool research.
Awesome. And you're here with Amii as a fellow and a Canada CIFAR AI chair.
That's right.
Now, I did want to talk a little bit more about the research that you're doing. So you got into reinforcement learning, which is, as you said, very cool. Can you go a little more into what exactly drew you to that area?
Yeah, well, I get confused very easily. And in reinforcement learning, you don't always need to know the right solutions to problems, right? You can set up the problem, and then the agent or the robot figures out how to solve it.
Yeah.
And, it can come up with solutions you didn't think of or anticipate. And just seeing that emergent solution was just so cool.
Yeah, just kind of watching it sort of develop.
Exactly.
Amazing.
Yeah. And I, like I said, I got into it because it was fun. We got to, use it for video games. And now in the past few years, it's actually started becoming really useful in the real world. And seeing that change from, purely academic, just ideas to actually being deployed to affect people is just so cool. It wasn't something that I was sure was going to happen, and I wasn't sure if it was going to happen, when it was going to happen.
You should tell people that you should that was.
Oh, I was absolutely sure it was going to happen, and I was betting on that from day one.
Very prophetic.
Yeah.
Right.
Yeah. Good point.
So we are talking about a specific aspect today, mostly about human in the loop. So can you give us just a really brief overview? When we say human in the loop, I've heard it a lot, but what do we actually mean when we use that phrasing?
Well, like AI, it means different things to different people. But for me, human in the loop is thinking about, well, AI is good at some things, humans are good at other things. Can we come up with ways of them working together to produce something that's better?
Right. And in our conversations, that's been a big part of it. It's the collaboration. It's between human and machine learning.
That's right.
Yeah.
Well, and part of it, if you go back to the early roboticists, thinking about, we're going to solve the vision problem over the summer. The vision problem ended up taking decades. And that's because humans are just really good at seeing the world and understanding, and it's really hard for robots. So let's leverage the things that humans are good at, and, super complicated long division, lots of arithmetic. We're not so good at that. Computers are amazing. So let's figure out how to partition that work.
And it also seems like something like that, when you're talking about vision, it's so hard to translate. It's not something you think about. And when you're building something that has to see, you need to know every step of that intimately. So it's interesting that it seemed like that was a problem that they thought would be solved very quickly.
Yeah. Well, and you think about common sense knowledge. Water is wet. Water shouldn't go on electronics. That's obvious to us after we ruined our first toy as a kid. But an agent, AI or physical robot, won't have that background knowledge unless it's done some very sophisticated learning or someone's put it in. So that's another example where humans just have this world knowledge that they can bring to a problem.
Yeah, and a lot of experience.
Exactly.
Seeing things and stuff like that. Where would human in the loop be most useful when we're talking about machine learning applications?
Well, so I think of kind of two main situations. The first one is where there's really that complementarity, that the machine is good at some things and the human's good at another. So for instance, if you think of, I want to play a chess game. So I could have a computer think of how to beat any human at playing chess, but it's actually quite difficult for a robot to go and move the pieces, especially if the human's on the board also. You want to make sure the robot doesn't hit the human. Whereas a human, it's very easy to move those pieces around, but we're not going to be able to beat a computer at chess. So you've got that kind of different strengths. But the other situation I think of human in the loop as being useful is where we really need that extra level of reliability or trust.
Yeah.
Because it's an important decision. So as a machine learning person, I don't want a fully robotic surgeon.
No, yeah.
I want a doctor that's there to supervise any AI decisions so that their background knowledge, their common knowledge, their experience can come in and make sure the AI isn't making a silly mistake.
Yeah. Yeah. Because I think naturally a lot of people, we just have more trust in other people. And I can see where it would be a sticking point, like, the idea of handing over your health, like you just mentioned, to something that's so different than what we're used to. Like, I'm a little scared when you say that. So now, is there a correct time when we're talking human in the loop? Like, is it the person should be the final decision maker? Should they be involved more earlier in the process? Is there a particular specific area?
So it's really application dependent.
Yeah.
But I try to think of it as if it's a human in the loop problem, the human should be involved from the beginning.
Right. Okay.
So if it's an important real world problem, we probably don't want nerds like me sitting in a basement coming up with a solution by myself, right? The machine learning people need to be talking with the subject matter experts and the people who are going to be using this platform. Because in the end, you need to design the system with the end user in mind.
So you're not just like getting somebody to sign off, like a doctor signs off at the end of this long process.
Exactly. And that's a great example because you could come up with situations where, the doctor is just moving from room to room to room, glancing, signing, and that might create an inappropriate level of trust.
Yeah.
Where, if the doctor isn't fully engaged with the decision making, just like, oh yeah, it's fine. And then it's kind of just, this pro forma rubber stamping the AI's decision, which defeats the whole purpose of human in the loop.
Now, in your own work, have you had a situation where kind of bringing those subject matter experts in early changed the way that you were doing things or kind of changed the path of the project?
Yeah. So for example, we're working with a startup, Illumia, that does flight training.
Right.
So we want to train, in some cases, it's students, it can be high school students, could be a little older, how to fly planes in simulation. And there, human flight trainers already have this detailed way of training pilots on the physical planes.
It's like very regimented and
exactly.
Checklists and all kinds of things.
Right. So I, as a machine learning nerd, knew none of that. So the way I would have approached it would have been just, throw the student in and let them figure it out. Whereas actually it probably makes more sense for them to build up from very basic skills and then gradually add more difficult skills and more complex things. But like the first assignment that a beginning pilot is given is called straight and level. Right. They need to fly the plane straight and keep it level.
I can see how that would be useful, yeah.
Yeah, it seems like a critical skill. Yeah. But that hadn't even occurred to me because it was so simple. Like, of course you would be able to do that. Well, not if you're a beginner.
Yeah, I mean, that's not something they teach in grade school, to my knowledge.
Not in my grade school, yeah. So that was being able to work with those professionals who know how pilot training works completely changed how we were going to approach the problem.
Is that an iterative process? Like, I assume they didn't just bring them in the beginning and then at the end, but that has to be a relationship that continues on.
That's right. The first challenge is really identifying good problems that AI can solve today. Because when you're talking about real world, companies often care about what we can do today, not 10 years from now.
Yeah.
So let's find a good problem, try to understand that problem, and figure out what's kind of the smallest thing that we could do that would bring value to the company. And that's absolutely an iterative process.
Now, I wanted to go a little bit back because you talked about reinforcement learning, and we love talking about reinforcement learning. And I had been reading a paper of yours recently that took the position that reinforcement learning inherently needs to be human. So can you talk a little bit about why you think that's such an important aspect of this one particular area?
Yeah. I mean, part of it goes back to what we were just talking about in terms of we've got to pick a good problem.
Yeah.
Right now, a reinforcement learning agent can solve a problem you give it, but it doesn't necessarily know what problem to solve.
Okay.
So for instance, normally in our classes, in a reinforcement learning class, one of the things you do is you hand a student or hand an agent a Markov decision process. But where did that come from? Does it come from the instructor? Does it come from a subject matter expert? Does it come from a book? In the real world, it's probably some combination of those.
Yeah. You think about the problem solving, but you don't think about the problem generating, or not generating, but defining, I guess, as you mentioned.
Yeah, I would say defining, because the agent is trying to maximize the reward. Yeah. And that's whether it's legal, whether it's ethical, whether that's what the designer wanted. So the designer usually comes up with a reward function, the agent maximizes that, and then the agent usually does a pretty good job. But then sometimes the human looks at what's learned and says, dude, that's not what I wanted. So a classic example is from OpenAI. There is this boat that was supposed to learn how to go through this course very quickly, and instead the boat learned how to go in circles in order to gather the most reward from hitting buoys. So it was maximizing its reward, but not accomplishing the task that the humans thought of.
Right, because the task was not really explained correctly to it, it sounds.
Exactly, because the agent was doing what it was told to do, not what the human thought they told it to do.
Yeah. And I guess I can think of situations where, the problem changes halfway through the process. Or maybe you weren't aware of what the problem actually was until you start trying to solve it.
Yeah. Yeah, well, or think about, I'm going to tell my agent that you're a water purification agent, and you need only the most pure water can be produced.
Right.
So a good solution would be to produce no water.
Yeah.
Right? Because then only the most pure. So, yeah. So, okay. So then, we need to produce some water. Okay. So we can produce some of the most pure water. But do you use an infinite amount of chemicals? That's probably not so good for the environment.
Yeah.
Or do you use an infinite amount of electricity? Well, you probably have some cost savings that you want to think about. So all of these multiple dimensions might not be initially obvious. And it's only when the agent comes up with ways of maximizing what you told it to, it's like, oh, well, of course I also care about.
And yeah, that's interesting in that kind of point that you brought about how we intuitively know a lot of this stuff and forces us to think, but if you said to me, produce water, I would not think producing no water is an option.
Exactly.
People need that. So this kind of base level training.
Yeah.
It's very interesting.
And that's also another point of where, that's where you need to have the experts in the room also, because they're going to be able to think of things that other criteria or optimization ideas that the machine learning people might not have thought of.
Now, I have talked to some other machine learning scientists who have said that, when it comes to this kind of thing, maybe human in the loop is not always appropriate. It could be limiting the effectiveness of certain machine models if we have to make sure that people are involved in the process. What is your thoughts on an approach like that?
They're wrong.
They're wrong?
No.
Right?
No, in some cases they're right. So I think there are many places which human biases can certainly be detrimental.
Yeah.
But one thing to keep in mind is every algorithm also has a bias. So part of it is a question of which bias do you trust more, which is more or less hurtful or harmful. But I think a deeper answer is more, we're going to bring human biases to the system, and we should be conscious of that. Right. So one of the things we try to do in our work is think about how a human can bias a system, but if the human is giving bad advice, we could still overcome that bad advice, show the person a better way of doing things, and let them say, yes, this is better, or no, really, listen to me.
Right.
So giving the human options to see that, oh, maybe I gave some suboptimal advice and the agent found something that could do that's even better.
That seems like a more realistic approach than just trying to eliminate any sort of human bias at all.
Yeah.
So we have a lot of baggage that we bring to things sometimes.
Yeah. Well, we all have baggage, but, data is biased. Algorithms are biased. Right. So there's, it's really hard to say, oh, this is a completely blank slate and it's completely fair. Like that's often hard to achieve in practice.
Yeah. And I think that there's almost a bias that people have sometimes in thinking that, well, if it's an AI model, if it's a machine model, it's objective, it's fair. And that's not really the case.
No, absolutely not.
What needs to be done, do you think, to move towards this approach where human in the loop is built in and inherent in all of the work that we do?
I think part of it is just recognizing that human AI collaboration can be a good solution technique.
Yeah.
And thinking about where it could apply. Because often AI people will think, I want to automate this. I want to figure out how to have my robot do everything. And that's absolutely appealing. Like if we can minimize human effort, minimize human risk, that absolutely makes sense. But if we think, if I want a robot to do this task and it's going to get a certain level of performance and take 5 years, or I could get a robot and a human to perform that same task at higher performance level and it takes half a year. Let's think about what's practical.
Yeah. And I guess it comes to the point that you were talking about what humans are good at, what machine learning agents are good at. If you do automate away the things that humans are not good at or unpleasant or whatever, that does leave more time and mental space to work on the collaboration that they are good at.
Yeah, exactly. So you might have read in the news recently how many stores are rethinking their self-checkouts.
Yeah, I've seen a lot of that.
Yeah, because it seemed like a good idea, but it turns out these machines are really not very good.
Yeah.
Because they're a pain in the butt and people steal stuff. And it turns out a lot of people actually enjoy interacting with a cashier. So being forced to interact with the machine actually reduces their value.
Yeah. I've never had a cashier tell me that, like, if there's something on the belt, I'm like, no, there's not. There's just not. And the bag's not on there yet.
Never had a cashier say, please wait for service. Please wait for service.
So a little bit more about that when we are talking about people collaborating with machine learning. What does that look like in your mind?
So it's clearly application dependent.
Yeah.
But I think to me, one of the important things is thinking about it as a collaboration.
Right.
So it's a teaming exercise. The AI should be doing things to help the human, but the human should also be able to anticipate the AI. The human should be able to understand what the AI is good at or bad at and be able to anticipate where it might come into problems or where it might be less trustworthy. Yeah. So it's building up that appropriate level of trust in the appropriate ways. If a doctor is working to diagnose a patient with an automated system, if the doctor can understand the system is good at these kind of diagnoses or good at this population of patients, but is not good at these other things, then understanding where they should, just trust the system because it's almost always right, versus, well, let's go get a second or third opinion from a different person, a different resource.
Right. And I mean, that is something we already sort of do. I mean, anybody who's worked with other people in a team, like, that other people have strengths and other people have weaknesses, and you sort of tailor things to what those are. So
exactly. Don't ask Matt how to spell something.
Oh, that's actually most of the other questions. It's just like a spelling test. So that
okay. Well, I quit.
Shorter episode. Now you talked about that kind of understanding. So it does seem like explainable AI is a big part of.
It can be, yes.
It can be. Okay.
So for some types of more simple tasks, maybe you can just see how the agent or the robot works and just kind of understand where it's good and bad.
Right.
But then for other tasks that require more reasoning, higher level decision making, then if the AI can explain why it did something or how it came to a certain conclusion, that can absolutely give a better model to the human. So think about when you're working in a team, you've got this theory of mind. You've got an idea of what Matt's thinking, what he's going to do, what he's going to be good at. And if I can explain, Scott, I'm sorry, I'm just not good at spelling, then that's an easy way to update your model.
Does that mean that when collaborating, do people need to understand the entirety of the model, or is it possible that it could just be certain aspects of it?
So realistically, it's usually going to be certain aspects.
Yeah.
Because often with our current AI models are so complex they can be extremely hard to explain to a person. And if you want to understand the entire model, it may even be infeasible.
Yeah.
But if you're just trying to figure out, why won't my Tesla turn left at this red light, that's probably something you can drill down to and understand. But if you want to understand how your Tesla drives, that's an extremely open-ended question and would be very difficult to explain because so much would go into all those different kinds of decisions the car could make.
And would you really use most of that knowledge?
Exactly. It'd be more likely to say, I'm considering 2 different car manufacturers. I've got this one tricky red light by my house. I want to ask car manufacturer A and car manufacturer B how they would handle that intersection, and that might inform my buying choices.
It makes me think of I think we've all had the experience where you're trying to run a program or something on your computer, and then it just brings up a something has gone wrong message. And you're sort of like, well, what do I do with that? That doesn't help. But at the same time, I don't want a full explanation of how every bit of code works because that's not going to help me.
Yeah, unfortunately, as a professor, usually the explanation is I walked into the room and just everything breaks. But yeah, please just tell me what went wrong and how I can avoid it next time.
Yeah.
Or, because if this was, an error occurred that was a one-time fluke and I'm never going to see it again, great, then I don't need to go into an in-depth explanation.
Yeah. A little error box that says Matt walked into the room. So that also sounds like it would help with the trust aspect that we were talking before. I mean, if you know why it's coming to a decision, it's easier to feel that surety that you're comfortable with that decision.
Exactly. Because if you realize, going back to the self-driving car example, if you realize your car just isn't very reliable when it's -40 and snowing, maybe you as a driver or consumer can then very quickly understand where you shouldn't trust it because it just doesn't have the right capabilities in certain circumstances.
Now, does that level of explainability, it sounds like it would differ from different applications and different...
Absolutely. Well, so there's applications, there's the sophistication of the end user, and also how they're going to use it. Because often explanations are there to allow the end user to do something rather than just provide, oh, that's interesting. You wanted the explanation to allow the user to do something or make a decision that they wouldn't be able to do without that information. So you need to think of the explanation that will help them make the kinds of decisions they need to.
And are there different general areas that you can see being much more important? Like we've talked about health a lot. That's something that strikes me as being very human in the loop specific.
Yeah, so there's high stakes domains where you really want multiple people coming to the table, working together and making an informed decision. There's liability. When something goes wrong, you want to be able to figure out what caused this and how can I fix it.
Yeah.
But there's also really that teaming when a human and AI are working together, depending on the application. This human and AI may be working together for weeks or months, and getting some explanations in the first week might make that whole collaboration better for the rest of the time.
And I mean, we've talked a lot about how humans can work with machine learning models, but from the other end of things, are there ways that you approach it to make sure that they can work more easily with the way that people work?
Yeah. So, I mean, you could also think of machines working with machines. Yeah. But thinking specifically about how you might help an AI to work with a human, one way you might do that is think of different biases that humans might have and try to account for that.
Right.
So for instance, if a human sees an answer more recently, they might be biased to prefer that answer again, even if it's not the best thing.
Right. It's just fresh in our minds.
Exactly. So that kind of temporal bias. So if we can think of some of those kinds of biases that a human might have, that could help us anticipate those. Or to put it a different way, if we think, I want to help my human learn how to do something, knowing something about human learning can help the agent better teach that human something, maybe teach that human about itself and how it works.
Well, in the interest of keeping people in the loop, are you able to talk a little bit about what your near future work is in this area? Anything specific that you can share?
Yeah. Well, we already mentioned the pilot training, which is pretty exciting because there's a huge pilot shortage. If we can do something to help AIs train pilots, get more pilots into the system, that would be great. Fewer delays. Another thing I'm really excited about from a fundamental research side is thinking about different ways that humans can interact with agents. So let's say you want to teach your robot to do something. You've got a robot at home and you want to teach it how to julienne carrots the way you like.
All right.
So you could give a demonstration, chop up the carrot for the robot, have it watch you. And if you're an expert chef, that could work fine. If you're someone like me, maybe you could explain the task to the robot and have it learn how to do it. Or maybe you could have the robot start learning it and then give it feedback like, oh, that was good. That was a really good part, but these 3 cuts were poor. So just giving, I can't demonstrate it, but maybe I can say what was good or bad.
Right.
And right now, a lot of people are looking at how to get that information from people, but there's not a good sense of when different kinds of information would be more or less useful or more or less easy for the person to provide.
All right. So kind of knowing when is the best way to use those different strategies.
Yeah. So that's exciting. I guess another thing I can mention, I work with a startup called AI Redefined. Okay. One of the companies we work with is in the smart grid and solar, and thinking
like solar energy.
Solar energy, yeah. So photovoltaic. Thinking about, can we predict how much energy we're going to get from the sun? Can we figure out once we have that energy, how we want to sell it to the grid? Eventually, could we get batteries that could store some of that energy in anticipation of future need? So that's something we could completely automate.
Yeah.
But it turns out, A, it's important, but B, humans have that kind of background knowledge. So it turns out that the company we're working with is in Australia, and there was a huge football match coming up. Soccer for the North Americans, right. But this football match was coming up and all of the country was inside at noon watching the sports with their AC on. So there's this huge spike in demand that if the AI was just looking at past trends, it wouldn't know about.
Yeah. But if you've got someone who's like a power engineer or something, they've come across, they know that's something to keep in mind.
Exactly. Figuring out all of these kind of external things that you might need to consider, which is probably outside of what the AI would normally think about.
Well, this has been a fascinating chat. Thank you very much for coming and talking a little bit about Human in the Loop with me.
Absolutely. Happy to do it, Scott.
Thank you.